Okay, today we are going to talk about data a little bit more. There's a lot that goes in with statistics and data, but one of the things that you might see coming up is something called a box plot or a box and whisker plot. They're the same thing. Box plot is the same thing as box and whisker plot, and you will see why it's called box and whisker once we create one. I am doing 2 video notes. We're also going to talk about distributions, and that's a really short section, and this is kind of a short section too, so what I'm doing is combining them together. We are going to do an example for box and whisker plot, and then I want you to do one on your own. Alright, so a box plot is a 5 box plot, or box and whisker, remember they're the same thing, is a 5 number summary. No, okay, sorry. Great, Buddha, who are you? I'm trying to do my work. Oi. Alright, sorry. God, real life here is happening, people. Real life. Alright, it's a 5 number summary. That shows the range of a data set. And not just range meaning highest minus lowest. It actually shows the whole spread of the data, which you'll understand a little bit better once I show you. Okay, back on track. Now the cat is gone. Alright, so again, you are writing everything down under the example. Alright, let's say this is how many cookies Joe sold each month. And so our data set is 51, 17, 25, 39, 7, 49, 62, 41, 20, 6, 43, and 13. So as you can see, there are 12 observations in our data set. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which means that he sold each month for a year. So 12 months in a year. This data represents a year. It's how many boxes he sold each month, or how many cookies he sold each month. So some months he did really well with selling 51 cookies, and other months he did not so well by selling only 6 cookies. So what we have in our 5 number summary is what goes into our box plot. And the 5 numbers that go into our box plot are the median, the lowest, the highest, the lower quartile, This has another name to it. I forget what the other name is, but it's like the lower box or lower, it's lower something. It's the first part of the data. The lower quartile, and then the upper quartile. And how we get the median, we already know. We put all the numbers in order and find the number in the middle. The lowest is the lowest number, highest is the highest number. In order to get the lower quartile, we find the median of the first half of the data, and the upper quartile is the median of the second half of the data. So I'm going to show you exactly how to get all of these things, the lower quartile and the upper quartile, and then how to draw it. I'm already out of room because I wrote so large on my paper, and I want to have it all on one page. So I'm going to flip my paper over, but make sure you have enough room to order numbers from least to greatest and to be able to draw a pretty big number line. Okay? And we'll make it all fit. So I'm going to flip my paper over, and I'm going to start the 5-number summary and then draw the box plot. The first thing I do is I take the numbers and put them in order from least to greatest, because that's always how I find my median. So looking at the numbers, I have 6, then I have 7, 13, 17, 20, 25, 39, 41, 43, 49, 51, and 62 is my highest. So I'm just going to make sure I have all the numbers by counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, I have 12 numbers. Okay, so the let me get a highlighter real quick, or a different color, so I can show you the median. Because I have an even number of data, I'm going to have to take the mean of the numbers in the middle. So if I have 6 numbers here, and 6 numbers here, then the 2 numbers in the middle are going to be the median, and I'm going to find the average. So let me grab. These 2 are going to be my median. So we're going to add them together. And then divide by 2. Two into 6 is 3, 2 into 4 is 2. So my median is going to be 32. So number 1, median 32. I'm just rewriting the numbers I had on the front. I wish I could remember the other name. Upper or lower? Lower and higher? Those might be the other names. It might be called higher and lower, or lower and upper. I'm not sure. But you'll see them. You'll know because it's the quartile. It's either the top quartile or the bottom quartile. Okay, so our lowest number we know is 6. Our highest we know is 62. So to find the lower quartile, we find the median of the first half of the data. So I'm going to look at the yellow part because that's the first half. Those are the first 6 numbers. And what I'm going to do is find the middle number of that 6. Because, again, it is an even set of data here. I have 6 numbers. I'm going to have to find the middle of those. And the middle of 6, 7, 13, 17, 20, and 25 falls between 13 and 17. So I have 2 here, 2 here, which means 13 and 17 are my 2 middles. So the median will be 13 plus 17, which is 30, and then 30 divided by 2 because that's how many numbers I added. So my lower quartile is 15. And then I have to do the same thing for the upper quartile. So in my upper quartile, it's this orange box. It's the second half of the data. There are, again, 6 numbers. So I'm going to have to find the median of between 43 and 49. And since 43 and 49 don't appear right after each other, I have to find the mean. So 92, 43 plus 49, 12, 8, 92. Then I do 92 divided by 2. 2 goes into 9 4 times with 1 left over, which means 2 goes into 12 6 times. So my upper quartile number is 46. So what I have here is 5 sets of numbers that describe all of the data. Okay? I've got a low of 6. I've got a high of 62. I've got a median of 32. So that falls somewhere in between. And what I'm going to show you is what it looks like in a picture. So what I'm going to do is I am going to draw a number line. And in this number line, it's going to be long. So I'm going to draw it by 2s. My increments have to be the same, remember. So I'm going to start with 6 because 6 is my lowest number. And I'm going to go all the way to 62, but I'm going to count by 2s. So, my middle number, okay, so let's just count by 2s. 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. I'm going to stop counting so you can do it as well. Make sure I didn't miss a number. 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. Okay. Alright, so mine is done. Now, remember, you have to make your increments the same. So I could have made a really, really, really long line and counted 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. But for me, counting by twos was a little bit easier. And it's still going to look fairly similar to what it would look like if I just wrote 1 through 62. And because my spread is so big, sometimes it helps to count by twos or fives, depending on the numbers that you have. If I look at the majority of the data that I have here in my 5-number summary, most of them are even numbers except for 15, so counting by twos makes sense. So what I'm going to do is I'm going to put a dot above each of these numbers in my 5-number summary. So I'm going to take 6 and I'm going to put a dot, and then I'm going to put a dot at my lower quartile, which is 15, and I know 15 isn't on my chart, but I know that 15 falls right between 14 and 16, so I can go ahead and put my dot there. Then my next one is 32. And then upper quartile or higher quartile is 46. And then the largest number is 62. Now that I have these dots, I'm going to create my box and whisker plot. And what that means is I'm going to start here with my lower quartile, and I'm going to make a box that goes all the way to my median. And I'm going to connect with the line my lowest to my lower quartile. This box represents the lower quartile. I think. Well, this is the lower quartile, this dot, right? This dot is the lower quartile. This dot is the lowest. Then I have my median. And then I'm going to make another box that connects my median to my upper. And then I use a line to connect my upper to my highest. And the reason why this is called a box and whisker plot is because you can see a box here, and then these two lines look like whiskers, like a cat or a dog would have. It's kind of, I mean, I think they eventually cut off the name box and whisker and just call it box for now. But what this represents is where most of our data lies. And what you can see by looking at this is the majority of our data, the majority of these numbers up here, fall in this box. And we know that because we found the median of each. And we can say that most of our data is in this box, and then we have some numbers that are lower and some numbers that are higher. But the majority falls in here. And that's the whole purpose of a box and whisker plot. You can answer questions by looking at this box and whisker plot. What's my lowest? What's the lower quartile? What's the median? Okay, if this weren't labeled, you might be asked to find the median number in the data set. And you would have to know that that is right here in the middle of this box. If you had to look at this data and they asked you for the highest number, you would have to know that it's the little dot here ending in our whisker over here, the highest number. And sometimes what you'll notice is that your whiskers will be different sizes. So I'm going to give you a set of data that you need to do a 5-number summary and draw a box plot for the data. And what you're going to see is a difference in the size of your boxes and the size of your whiskers. And that really tells you, where does most of my data lie? Why is one box, what if this box over here extended out here and was way bigger than this box? Then most of your data lies over on this side. So really it's looking at what your data is. Okay, so your to do is find the 5-number summary and I don't know what I just did there, and draw a box plot for the data set. So what I'm going to be giving you is, your data set is for car speed data. It is the average number that a car drives in a school zone. Let's just say that. Car speed data, the average that a car drives in a school zone. So your numbers are, and I'm not giving them to you in order because I'm not that nice, 25, 35, 27, 22, 34, 40, 20, 19, not 2019 together, they're two separate numbers, 23, 25, and 30. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data. Oh, I just made it real easy for you by not having you do a mean to find the median. That's okay. Do your 5-number summary and then draw the box and whisker plot. My suggestion to you is that you start at 19 and you go to the highest, you go one above the highest number and count by twos. So do 19, 21, 23, 25, 27, 29, 31. That's my suggestion when you're making your box and whisker plot, because what you'll see is that several of the number, it's just easy to do it by twos and not have to draw a really long one unless you want to. So again, my suggestion, go by twos, but do odd twos. So 19, 21, 23, 25, blah, 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 blah. All right. You can stop this video and do that or come back to it. What I'm going to go to now is distributions. And this is just called the shape of data and distributions means how is the data distributed? What does it look like? How are the numbers passed out if you're looking at a graph? Okay. So words that we use with the shape of data is cluster, and a cluster is data or data that are grouped closely together a gap are numbers with no data value. I'm going to show you an example of these. Most of these. A peak is the mode, which is the most frequently occurring values. Symmetry is when we look at a graph, we find the middle of that graph and it looks very similar on both sides. So the left side of the distribution looks like the right side. An outlier is a rare occurrence, meaning it doesn't happen often, of a value that may skew the mean or median. And I'm going to explain that one the most to you because outlier will really change your data. Okay, so with these 5 words, these are what we use when it says describe what the data looks like, or what's a conclusion that you can say when looking at the data. These are words that we can use when we look at the data to describe what it looks like. Okay, and I'm going to give you an example using a dot plot. And the title of this dot plot is number of states visited. And let's say that I had a whole list of, I took a poll and I had a certain amount of observations, and now I'm going to make a dot plot to describe the data. So I'm going to label my dot plot from 10 to 19. And it's not perfect, but it works. All right, so my data includes 1 at 10, 1 at 11, 1 at 12, 1 at 13, 1 at 14, and 1 at 19. My data also includes 2 at 10, 2 at 11, 2 at 12, 2 at 13, and that's it. Now it's 3 at 10, 3 at 11, 3 at 12, and 3 at 13. And remember, I want my dots to be as lined up as possible so I can really see it. Then I have 2 more at 11, 2 more at 12, actually I have 6 at 12, so I'm going to put another one. And if these 5 were spread out more, it would look like that I had more on 11 than I did at 12. So again, like lining them up is important, because when I look at this, I can clearly see that 12 has more. Okay, so here's my data. Here's my dot plot. How many observations are in the data? So all we would do is we would count the dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. It looks like $19 sets of data, or 19 people were observed. So any number that I got would have, like any mean I got would have to be divided by 19. All right, we're not going to talk about mean right now though. What I want to show you is, and I'm going to use my highlighters, a cluster. Data that are grouped closely together. This is a cluster. Oops, sorry, you can't see it. You can see all of the numbers lie in this area. I could even take 14 out if I wanted to. Most of the data is right in here because I only have one observation in 14. So this would be where my cluster of data is. Okay, I'm going to use a different color and show you a gap. Numbers with no data value. My gap is here. Nothing happens 15, 16, 17, or 18. There's a gap because I have a number at 14 and I have a number at 19 and nothing happens in between. Nobody visited 15, 16, 17, or 18 states of the people I observed or asked or surveyed. Okay. The biggest thing here that you'll see, I guess we could do a peek. I'm going to run out of highlighters. I don't know if I have enough. I'll just show you this. A peak, I'm going to keep it in purple. This could be a peak. A peak means this is the most frequent number that occurs. 12 happened 6 times, whereas 11 happened only 5. So the peak of my data is 12. Okay, and then finally, I have an outlier, and that outlier is 19. Look how far away 19 is from my cluster. It's way out there. And what that means is that when I am finding the mean, my mean is going to be larger because I have that 19 that's way out there. That 19 makes my number go higher when I add them all up in order to find the mean. If I had an outlier way down here that was like 2 or 3 states visited, that would also skew my data. It would make it go lower. It would be less likely that my mean is close to 12. We can see clearly that our data is kind of here. It kind of lies in this 11 to 12 area. But if I get a number that's like 2 or a number that's like 19, that moves my data around a lot when I'm finding the mean or mode. Not mode, mean or median. It's really going to change my number because those are the numbers that you're adding together or that you're finding that go in the middle. And sometimes they really mess up your data. If this plot here did not include 14 and 19, this set right here would almost be symmetrical because the middle of it would be right here where my pen is, and it almost is symmetrical, meaning it looks very much the same on both sides of the pen. But because I have 14 and 19, those don't make my graph symmetrical. So when we look at data, when we talk about data or distributions, we've got to use these types of words: cluster, gap, peak, symmetry, outlier. Those are things that we can talk about that make us sound a lot smarter when we're talking about data. If I look back here at my box and whisker plot, I can also see here that I'm going to have whatever falls into here are kind of outliers. Over here, kind of an outlier, because most of my data is in this box. Look how far this is from the median. Look how far the lowest is from the median. Okay, that's the middle. And when you have numbers that are really high and far away from the data, it changes the way the data comes out. And I never ever cared about looking at data until I went to college and I had to take a statistics class, and all of this stuff I had to relearn. And then in my job now, all we do is look at data. All I do is look at your test scores. All I do is look at how well you did on test A, B, C, and D. Is there a reason why you're either doing better? Is there a reason why you're not doing so well? What's going on? Are your scores pretty much the same all the time? Like, I have to, those are the kinds of things that I have to look at when I look at your data. So yeah, we look at data a lot. Okay, you look at data when you watch sports. You look at data, I don't know. There's probably a ton of other things, but at this point of the night, I'm really tired and you don't want to hear me talk anymore anyway. So, do your box and whisker plot for the car speed data. Find your 5 number summary, and then see, can you talk about the data that you see there using these words? I don't know. Try it out. All right, more tomorrow.